What's up? I'm Vin, and I'm going through the August 2024 Geometry Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. First, I'm doing the part 1 questions, the multiple choice. There's 24 questions here, and each one is worth 2 credits. Question 1, in right triangle LMN below, LN equals 8, MN equals 15, and LM equals 17. If triangle LMN is translated such that it maps onto triangle XYZ, which statement is always true? So for this one here, one thing we have to know is that if we translate this triangle, the resulting triangle is going to be congruent to the original because a translation is a rigid motion. Okay, so we're just sliding this triangle so the size of the triangle and the shape does not change. So here, if we slide this triangle over here, we're going to name this new triangle XYZ. But one thing to notice is that we're starting at L, which is in the top position here. So when I write triangle XYZ, I'm going to start at the top position like this, and then we have LMN, so we go from the top to the right side, and then we go to the left. So when I write my Y and my Z, I'm going to go to the right, and then I'm going to go to my left like this. So the order of the letters is very, very, very important. So now what we could say is XZ is also 8 units long. The bottom side here, YZ, is also 15 units long, and then the hypotenuse XY matches this hypotenuse, so we could put a 17 here. And now we want to know which statement is always true. Well, xy equals 15 is not always true. And then we could look next, yz is equal to 15, but this is saying 17, so this answer is out. And then we have the measure of angle z is 90 degrees. Yes, this one here is always true because notice that angle n over here, that's the last letter that shows up in the letter arrangement, is 90 degrees, and that corresponds to the last letter here. So z has to be at the right angle. And now the last answer choice is no good because the measure of angle x up here, this is one of the acute angles of the right triangle, would have to match angle L. Okay, so I could say the measure of angle L is equal to the measure of angle x. That would always be true, but that's not what was said here. So 4 is out, 3 is definitely our answer. Question 2, we have directed line segment KC has endpoints K at -4, -2, and C at 1, 8. And point E divides KC such that the ratio of KE to EC is 3 to 2. And we want to know what are the coordinates of point E. So one way to do this question would be to use the formula. So when I have my points here, the point that is all the way to the left, I call x1, y1. And then the point that goes all the way to the right, we're going to call x2, y2. And what we have next is that the x coordinate that we're looking for is equal to the starting x value, x1, and then the ratio we call P to Q like this. This is just going to help us understand the formula. So I have x1 plus P over P plus Q, and then I multiply that by x2 minus x1. Okay, so this formula will get us the answer right away. We just have to be careful here that we're calling x1, y1 the point all the way to the left, and we have to make sure that this ratio is going from left to right. Notice that it's going from KE to EC, which brings us from K to C. So this so far is looking good. So I just plug in, and we're going to have -4 plus, and then P is 3, and we divide by P plus Q. And if I do 3 plus 2, that's going to give us 5. And then we multiply by x2 minus x1. So we have 1 minus -4. And then we simplify here. We're going to have x equals -4 plus, we have 3/5 of 1 minus -4 is 5. And now 5 over 5 cancels, and we have x equals -4 plus 3 is going to give us -1. And the only answer choice that has a x value of -1 is choice 1. Now, if you can remember this formula, then excellent. But if you can't remember this formula, then a nice way to do this would be to draw this out. So now that we have this drawn out, let's count the rise over the run, how much we have to go up and over to get from point K to point C. So we're going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going up 10. And then we're going over 1, 2, 3, 4, 5. And what I want to do with this is I want to divide each of these pieces by 5. And the reason I'm dividing by 5 is that if we have a ratio of 3 to 2, that's 3 equal parts to 2 equal parts, but that's a total of 5 equal parts. So if I divide each of these pieces by 5, now I'm going to be thinking, let's go up 10 divided by 5 is 2, and go over 5 divided by 5 is 1. So now watch what happens. I'm going to start at point K, and I'm going to go up 2 over 1. So I'm going up 2 over 1. Then I'm going up 2 over 1 again. I do this again. and I do this a few more times, and notice that I have a line segment now broken into 1, 2, 3, 4, 5 equal pieces. So point E has to be located here, because notice that I have 1, 2, 3 congruent pieces to the left of the highlighted point and 2 congruent pieces to the right of the highlighted point. So point E would have to be here, and let's identify the coordinates. We're going to the left 1, and we're going up 1, 2, 3, 4. Okay, so negative 1, 4 here is definitely the point we want. Question 3, in right triangle DAN, the measure of angle A equals 90 degrees, and we want to know which statement must always be true. So for this one here, we could just draw out a right triangle. So we have a right triangle over here, and we're going to name it DAN, but angle A has to be 90 degrees. So the letter A is going here, and then I'll put D here and N here. And for this one, if you really understand the concept of cofunctions for sine and cosine, then this question won't be too bad. The thing to know about sine and cosine is that if you plug in a pair of complementary angles into sine and cosine, they're going to be equal. So let's say I take something like 50 degrees and 40 degrees. These two angles here are complementary because 50 plus 40 equals 90. So if I did something like this, sine of 50 degrees, and I set this equal to cosine of 40 degrees, I could say this equation is true because 50 plus 40 is 90, and sine and cosine are cofunctions. So when we plug in pairs of complementary angles, the values are going to be equivalent. So knowing that here, I can see angle D and angle N are complementary. So scanning the answer choices right away, 2 jumps out at me that cosine of D is equal to sine of N. Now, let's say you forget that idea about sine and cosine. That's fine. What you could do then is use the mnemonic SOHCAHTOA and set up trig ratios to answer this. Now, they didn't tell us the lengths of the sides here, so we could just pick out any values we want because we're looking for the statement that must always be true, which means for any triangle, which means any triangle that we choose. So I'm going to put 3, 4, 5. That's one of the most basic right triangles we could use in trig, the 3, 4, 5 right triangle. And we could use, there are other ones. We could use 8, 15, 17 from question 1. That would also work, but this is the one that I want to go with. So now cosine of angle D, I'm going to look over here at this angle. So we're looking over here at angle D, and I'm going to find the cosine of angle D. So I'm looking adjacent to angle D. That side is 3 units long, and then we divide by the hypotenuse, which is 5 units long. Okay, so just so we're clear on what this means here, we have the phrases opposite, adjacent, and hypotenuse. Okay, so opposite, then we have adjacent, and we have hypotenuse. So when we are setting up these ratios, we have to think about the angle that we're starting at. So if we're starting at angle D, the side over here, DA, is adjacent to this angle. It's next to it. Technically, we could say 5, like this side over here is next to the angle, but it's opposite of the right angle. So no matter which angle we're talking about, D or N, this side is always going to be the hypotenuse. Okay, but the opposite and adjacent change depending on which angle you're starting at. So cosine of D, we could say, is 3/5. So now let's see what happens when we find sine of angle N. So we have sine of N equals, and if I start at N, notice if I'm over here now, so let's shift our focus to this corner of the triangle here. If I'm setting up the ratio for sine, sine is the ratio of the side opposite of the angle over the hypotenuse. So if I'm over here at angle M, this side over here, that's 3 units long, is opposite. This side over here is opposite of angle N. It's also adjacent or next to angle D, but it's opposite of angle N. So when I set up my ratio, sine of N is equal to opposite of N is 3 over the hypotenuse is 5. And notice that we get the exact same thing here. Okay, so that's 2 ways to do this question. Whichever one you think is easier is the one you should go with. Question 4, in the diagram below of parallelogram RSTV, diagonals SV and RT intersect at E. And we want to know which statement is always true. So choice 1, we have SR is congruent to RV. This would always be true if they had started us off with a rhombus, but all they told us was that this shape here was a parallelogram. So this is not something that has to be true all the time. It would be true all the time if we had started with the rhombus. And what you could do is just look at the picture. The way this parallelogram was drawn, I think it's visually obvious that SR looks shorter than RV. So here's at least one case where this is not true. So choice 1 is out. Next, we have RT is congruent to SV. This statement is not always true. It may be hard to see which one here is the longer diagonal, but we can draw a bunch of parallelograms and see there are cases where it's clear which one is going to be the longer diagonal than the other. This would always be true if we had started with a rectangle. Okay, a rectangle is a parallelogram with congruent diagonals. Okay, a rectangle has 4 right angles, but what we could say about a rectangle is that the diagonals are always congruent, but we're not starting with a rectangle necessarily here. So that's how we know choice 2 is not always true. So choice 3, what we have is SE is congruent to RE. This one here is not necessarily true because this is an extension of choice 2. SE congruent to RE would tell us that the diagonals are congruent and that they were bisected. So that's why here, this is once again using the idea that the diagonals are congruent, which would only be true if we were starting off with a rectangle. The one we could say is 100% true is choice 4, and it's not just because the other answer choices were eliminated. This one here is saying that RE is congruent to TE. One very important thing to know about parallelograms is that the diagonals bisect each other. Okay, so this is true for all parallelograms. The diagonals bisect each other, which tells us that the diagonals cut each other in half. So I could say that RE is congruent to TE, and I could also say that SE is congruent to VE. This is always true for any parallelogram. Question 5, in triangle SNA below, line UE is parallel to segment NA. If SU is equal to 3, SN is equal to 11, so this entire piece here is equal to 11, and then we have EA is equal to 13, what is the length of SE to the nearest tenth? And I'll just put an X here. So for this one, there's a few different ways we could do this, but one way would be to find this segment over here. So we do 11 minus 3 is 8, and we label over here. And then from here, we could use the side splitter theorem. So the side splitter theorem says that when we have a triangle, when we introduce a line that intersects the triangle, and that line is parallel to the third side, then the line introduced cuts the two sides proportionally. Okay, so since this line intersects the triangle through two sides and it's parallel to the third side, it's going to cut those two sides proportionally, which allows us to say then that 3 over 8 is equal to x over 13. And then from here, all we have to do is solve for x. So we cross multiply. We're going to have 8 times x is 8x, and this equals 13 times 3 is 39. And then from here, we just do the division, and this we could just type in a calculator. So if you do 39 divided by 8, that's going to give you 4.875. And they told us to round to the nearest tenth. So at the tenths place, we have an 8. To the right is a 7, so we round this to 4.9. Okay, so we'll say x equals 4.9 once we round, and this will match up with choice 3. Now, before we move on, I want to see this question one more way, just in case you forget the side splitter theorem. So we're told here that this line is parallel to this segment. And what that's going to do is it's going to create two similar triangles. So the triangle at the top here, triangle SUE, is going to be similar to triangle SNA. And the reason being is that when we have parallel lines cut by a transversal, the corresponding angles are congruent. So notice that the small triangle here, triangle SUE, this triangle here, so far what we have is that angle U over here is congruent to the big triangle's angle N. So if I draw the big triangle like this, we have triangle SNA, that these two angles here are congruent. And they also share angle S. So since the two triangles have two pairs of congruent angles, they're similar, we could say, by angle-angle similarity. So what I'm going to do now is label. We have SU is equal to 3. So I'm going to call this 3 over here. And then they told us SN is equal to 11. And next we had EA is equal to 13. So if I put an X over here, SE is equal to X, but the entire distance from S to A is X plus 13. And now since these two triangles are similar, I could set up a proportion to solve. So I'll say 3 over X, I'm comparing the left side to the right side, is going to be equal to 11 over X plus 13. And from here, I just do the algebra. I cross multiply. So I have 11 times X is 11X. And then this is equal to 3 times X is 3X. Plus 3 times 13 I distribute is equal to 39. So what I did over here, I did this math in my head, but I did 3 times x plus 13. So I had to make sure to distribute, and that gave us this right side here. So now I just solve for x. I go minus 3x on both sides. And on the right side, these terms cancel. And on the left side, we have 11 minus 3 is 8. So 11x minus 3x gives us 8x. And this is equal to 39. And once again, we're doing 39 divided by 8 to solve for x. And that's still going to give us, we had 4.875, which rounded to 4.9. So either way, we're getting choice 3. Question 6, many roofs are slanted to prevent the buildup of snow. As modeled below, the length of a roof is 5.5 meters, and it rises to a height of 2.5 meters. The angle of elevation of the roof to the nearest degree is, and for this one, what we're doing is we're looking for this angle over here. So we'll call this over here, this angle x. And I know we're looking for this angle because the angle of elevation starts from the bottom and it goes up like this. Okay, so that's how we know we're looking for this one. And now let's think about what these sides represent. So if we're looking for this angle over here, then we know this side over here is opposite of x. Okay, so this side here is opposite, and across from the 90-degree angle is the hypotenuse. So then what you want to think about is the phrase SOHCAHTOA. Okay, so SOHCAHTOA helps you choose the correct trig function. So we're thinking of SOHCAHTOA, and we ask ourselves which trig function uses opposite and hypotenuse in the ratio. And that would be O and H, which corresponds to sine. Okay, so sine of the angle x is equal to the ratio of the side opposite of x, which is 2.5 meters long, over the hypotenuse is 5.5 meters long. And now our goal is to solve for the measure of angle x. So here, what we're going to do is we're going to do the opposite of sine, which is sine inverse. So we're going to say x is equal to sine inverse of the ratio 2.5 over 5.5. Okay, it's very important to know that when you have sine, cosine, and tangent, you feed them an angle and they give you a ratio. But the inverse trig functions, you feed them a ratio and they bring you back to the angle. So here I have the calculator reset, and when the calculator is reset, it goes by default to radian mode. So I'm going to go to mode and I'm going to switch this over to degrees because we want to know the measure of the angle to the nearest degree. So I press enter, and now I go to the main screen and I'm going to press second sine to pull up sine inverse, and I'm doing 2.5 divided by 5.5, and this will give us the angle. So to the nearest degree, we look at this angle. The ones place here, we have a 7, to the right is a 0, so we would round this to 27 degrees, and this would match up with choice 3. Question 7, in the diagram below, CT is parallel to AR, and ACE and RC are drawn such that AC is congruent to RC. If the measure of angle ECT equals 75 degrees, what is the measure of angle ACR? For this question, notice that CT and AR are lines because they have arrows going in both directions above CT and AR here. ACE is a ray because we have an arrow going in one direction, and RC is a line segment. So I just wanted to point that out before we get into the question. So let's use all this information now. We could say these two lines here are parallel, and we have AC is congruent to RC, and we're told the measure of angle ECT is equal to 75 degrees. And we want to know what is the measure of angle ACR. So I'll just put an X over here like this. Well, this triangle on the inside is isosceles. So I could say that these two angles at the bottom here are going to be congruent. And then the next real big idea that we need is that when we have parallel lines cut by a transversal, the corresponding angles formed are congruent. So I could say here that this angle here in the top right corner of this section of 4 angles is congruent to this angle over here in the top right corner. So these two angles have to be equal in measure. So we're going to use that idea over here when we have these parallel lines cut by ray ACE. This angle here of 75 degrees, I could also say this angle here is 75 degrees because they're in the same relative position, just the same way we see in this diagram here. And then this triangle here is isosceles. So I could say that this angle here, CRA, is also 75 degrees. So now we have a triangle and we know 2 of the angles and we want to find the third. So we could add these 3 things together and set the sum equal to 180. Okay, so we have 75 plus X equals 180. and we just work this out. 75 plus 75 is 150, and we have plus x equals 180, and now we just subtract. So we're doing minus 150 on both sides. And from here, 150 minus 150 cancels, x equals 30. So the missing angle here, what is the measure of angle ACR? That angle is equal to 30 degrees. Question 8, in the diagram below, triangle ABC has medians AX, BY, and CZ that intersect at point P. Now just know the intersection of the three medians, that point is called the centroid. And what the centroid does is that it breaks the medians into a ratio of 2 to 1. So this is the longer piece here. This piece is going to be twice as long as this piece over here. And the same thing is true for the other medians. And then we have if AB is equal to 26. So this entire side here is 26. And then we have next, AC is equal to 28. So down here, this entire side is 28. And PC is equal to 16. So we were given this length over here. What is the perimeter of triangle CZA? So let's highlight that. So we have triangle CZA. That is this triangle over here. So we want to find this perimeter. So we're going to find the side lengths all around, and we're going to add them all up. So one thing to know is a median goes from the vertex of a triangle to the midpoint of the opposite side. So what that tells us is that this point here, Z, is the midpoint of AB. So it breaks AB into two equal segments. So I could take 26 and divide it by 2, and I could say that each of these pieces here are 13 units long. So that tells us the length of AZ. But now, how do we find the length of ZP? Well, remember, when the medians intersect at the centroid separates the medians into two segments that are in the ratio of 2 to 1. So you see how ZP is the shorter segment here? We just have to take 16 and divide it by 2, and we're going to get 8. And that tells us the length of this segment here is 8 units long. So now to find the perimeter, we're just going to add all of these together. So we're going to do 28 plus 16 plus 8, and we're going to add 13. And this we could just type in a calculator, or we could add it up and then check our answer with the calculator. So I'll just add this up. We have 8 plus 6 is 14, plus 8 is 22, and then we have 22 plus 3 is 25. We carry the 2. 2 plus 2 is 4, plus 1 is 5, plus 1 is 6. So the perimeter of the triangle is, we have choice 2, 65 units long. Question 9, in right triangle ABC below, the measure of angle C equals 90 degrees, AC is equal to 12, and the measure of angle A equals 25 degrees. And we want to know which equation is correct for triangle ABC. So for this one, if you look at all the answer choices, you'll see that every answer choice includes tangent of 25 degrees in there. So now let's think about SOHCAHTOA. If we're thinking of the tangent function here, then we're going to be using this piece, the TOA in SOHCAHTOA. And how that works is we look at the angle, which is over here at 25 degrees, the angle at point A. And we're going to look at the side opposite of this angle. So opposite of this angle is side BC, which is labeled with a lowercase a. So this is the side opposite of angle A, and we're going to be looking at the side adjacent to angle A, which is the side next to it over here. And I could say that this side here is next to angle A, but it's the side opposite of the right angle. So this side here is the hypotenuse, which I'm just going to abbreviate like this. So now for tangent, I'm setting up the ratio of the side opposite of the angle, which is lowercase a, over the side adjacent to the angle, which has a 12 here. And now I just have to do the algebra. I'm going to call this tangent of 25 degrees over 1 and cross multiply. So what we're going to have is a times 1 is equal to a, and this is going to be equal to 12 times tangent of 25 degrees. I'll just make that neater. We have tangent of 25 degrees. And now we just scan the answer choices, and this is going to match up with choice 2. Question 10, triangle HUS is shown below. If point G is located on US and HG is drawn, which additional information is sufficient to prove that triangle HUG is congruent to triangle HSG by SAS? So for this one here, we need point G to be located at the middle, because if it's not located at the middle, when we connect H to G like this, then we wouldn't have two congruent triangles. So for one, point G has to be in the middle of SU. So it has to be the midpoint of line segment SU. And then from here, what we could say is, if our goal is to prove these two triangles are congruent by SAS, what we need to happen is we need these two pieces to be the same. We need G to be the midpoint. These two triangles share a common side, but the angles between these two marked sides, or the two pairs of marked sides, have to be congruent as well. So these two angles would have to be the same, but since they form a linear pair, if angles form a linear pair and they're congruent, that means they're both 90 degrees. So now we scan the answer choices. HG would have to be the perpendicular bisector of line segment US to prove these two triangles are congruent by SAS. Now, why are the other answer choices wrong? Well, for choice 1, if we say HG bisects US, if I don't draw this exactly to scale the way it looks over here, so I just draw something like this. If I drop down a segment bisector like this, you could see that this triangle and this triangle are not guaranteed to be congruent. So that's why it's not enough just to say that HG is a bisector. If we say HG is an altitude, I could take that same triangle here and I could drop down an altitude like this, and you could see that these two triangles are not congruent. So this one here is not enough. And then same thing if I draw something like this and I draw in an angle bisector like this. So I chop that angle in half. These two triangles here are not necessarily going to be the same. So that's why choice 3 is out, definitely choice 4. Question 11, the area of the base of a cone is 9 pi square inches. The volume of the cone is 36 pi cubic inches, and we want to know what is the height of the cone in inches. So for this one, we could go to the back of the Regents to the formula sheet and get the formula for the volume of a cone, which is 1/3 pi r squared times h. And now we just plug in. They told us that the area of the base of a cone is 9 pi square inches. Well, this question is actually a little bit tricky. So this is hard to plug in for if you don't know the anatomy of a cone. So if we think about a cone, I'm just going to draw it out like this. The base of the cone is 9 pi square inches. The base of a cone, if it's facing like this, is going to be a circle. Okay, so the base of the cone is a circle, and the area of a circle is pi r squared. So the piece that we're actually replacing with 9 pi is this entire piece here. Okay, or what we could do is we could say the area of the base is 9 pi, and we could plug in for the area and say 9 pi equals pi r squared, and we could use that to solve for the radius. So if we do it this way, we divide both sides by pi like this. Pi over pi cancels on both sides, and it tells us r squared is equal to 9. And then we take the square root of both sides, and this will tell us that r is equal to the square root of 9, which is 3. So now we have the dimension for the radius. So we could just plug everything in nicely here. So we have now that the radius is equal to 3 inches. The volume of the cone is 36 pi cubic inches. So I'm going to replace V with 36 pi. And now we have 1/3 times pi times r squared. So we're doing 3 squared, and then we're multiplying that by h. So now we just have to do the algebra here. We have 36 pi equals, and now we have 1/3 times pi, and then 3 to the second power is 9, and we're multiplying by h. Well, if we do 1/3 times 9, that's just going to give us 3. Okay, we're doing 9 divided by 3 is 3. So now we have 36 pi is equal to 3 times pi times h. And then all we have to do to solve for h is we're going to divide both sides by 3 pi. And from here, we have 3 pi over 3 pi canceling, and this gives us h equals pi over pi cancels, and 36 divided by 3 is 12. So the height is going to be 12 inches. Now, if that algebra was a little intimidating, what you could do is you could take 36 and you can multiply it by pi, and you have this number here. And then on the right side, what we had was 1/3, and then we multiply that by pi, so that's second and this up arrow here. And then we multiply that by 3 squared. Okay, so we're doing this times 3 squared, and we get this number. So what we would have in equation form is we have this number equals this number times h. So if I do this number here, and then I divide it by this number, notice that I get the same exact answer here of h equals 12 inches. So you could also use the calculator here, but if this algebra was fine, then just do this algebra to get h equals 12. Question 12, on the set of axes below, A, B, C, D, E, F, G, H, and I, J are drawn. Which segment is the image of AB after a dilation with a scale factor of 2 centered at -2, -1? For questions like this, the first thing I like to do is identify the center on the graph. So we have a center at -2, -1. So there's the center. And this part I reread a few times if I have to really understand what the question is asking. We want to know which segment is the image of AB. So that means we're starting at AB and we're landing somewhere else. Okay, so this is counting as the pre-image, which means once again, we're going to start with this line segment here. Okay, we're not going from the image back to the beginning to the pre-image. We're starting here at the pre-image and we're going to the image. So we are dilating with a scale factor of 2. So the method I like to use for questions like this, I call it the rise over run method. So I go from the center here. So this is our center. Let's say I call the center O. And I go rise over run to get to the endpoint. Let's say I go to B first. So I'm going to go up 1, 2. So I'm rising 2. And then I'm going to run 1, 2, 3, 4. Okay, and this is to go from O to B. Okay, so to go from O to B, I go up 2 and I go over 4. So then what I'm going to do is I have a scale factor of 2. I multiply this by 2. So I'm going to go up instead 2. I'm going to go up 4 and I'm going to go over 8. Okay, and this is going to bring me from O to B prime. And now let's see where this brings us. We go up 1, 2, 3, 4 and over 1, 2, 3, 4, 5, 6, 7, 8. So this is bringing us to point F. So right away, it's looking like choice 2. It's going to bring us to line segment EF. But one thing we could do to be 100% sure is we could use the rise over run method to bring us from A to hopefully point E. So now for OA, we're going to count the rise over run. We're going up 1, 2, 3, 4, and to the left 2. So we're going up 4, and we're going to the left 2. And now we apply the scale factor of 2, and that's going to take us from O to A prime. And let's see what the rise and run is going to be. So we're going to go, instead of up 4, we're going to go up 8, because we're just going to multiply by 2. And instead of going left 2, we're going to go left 4. And we're starting from O, and that's going to bring us to A prime. So now I go up 8. I go up 1, 2, 3, 4, 5, 6, 7, 8. And I go to the left 4, 1, 2, 3, 4. And this does, in fact, bring us to point E. So choice 2 is definitely correct. Question 13, trapezoid ABCD is graphed on the set of axes below. Which transformation would map point A onto A prime at 3, -7? So for this one here, we're going to plot point A prime, and we're also going to identify the coordinates of A. So A is located at -1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3. So A is at -7, 3. And let's plot this point. So we're going to the right 1, 2, 3, and we're going down 1, 2, 3, 4, 5, 6, 7. So this is the location here for A prime. It's in quadrant 4 at 3. So I'll just make that neater. It's going to be at 3, -7. So one thing to notice here is that the X and Y from point A to point A prime just switches. Okay, so the X -7 and Y 3, they just switch to 3, -7. So if you know your transformations, when XY switches to YX, this is coming from a reflection over the line Y equals X. Okay, so this is from a reflection over the line Y equals X. And that would tell us choice 1 is the answer. Now, you could, if you just look here, see that if I drew in this line like this as the line of reflection, you could see that A is going to go across this mirror line like this, and that's going to bring us right to A prime. Okay, the bigger idea for lines of reflection is that the line of reflection acts as the perpendicular bisector of the point and its image. Okay, so these segments here would be equal in length, and these two lines would intersect at 90 degrees. But now, why are the wrong answers, or why are the other answer choices wrong? So let's see. If we were to reflect A over the y-axis, that would send us somewhere over here in this neighborhood in quadrant 1. So that's how I know choice 2 is out. Rotating by 180 degrees. Well, when you rotate XY 180 degrees, what's actually happening here is you're doing -x, -y. Okay, you are changing the sign of the X and the Y. So that would actually send us to the point 7, -3. Okay, that would send us to, let's see, 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3. That would send us over here if we reflected 180 degrees, over the origin. And you could even see here that if I were to draw in a line like this, see how this connects on a straight line, and it brings us right to this point here. So that's how I know, like, this part here is good. We could also draw a circle and then just expand it out and see if I line this up nicely. So I'll just go a little bit out here and then move it over, that when I connect these points here by a circle, see at 0, 0, we have our center, and these are on opposite sides of the circle like this. See how A to this point over here is acting as a diameter. So that's how, once again, I know that choice 3 is no good. So we could chop off choice 3. And now a rotation of 90 degrees counterclockwise would send us in this direction here, okay? It would send us towards quadrant 1, which would not bring us to this point over here at 3, -7. So that's how I know this one is out. Choice 1 is definitely our answer. Question 14, a storage building is modeled below by a hemisphere on top of a cylinder. The diameter of both the cylinder and hemisphere is 12 feet. The total height of the storage building is 30 feet. And then we have, to the nearest cubic foot, what is the volume of the storage building? So one thing we should look at here is that we have the diameter of the cylinder and hemisphere is 12 feet. So if we have this diameter here is 12 feet, so is this diameter here for the hemisphere on top. This is also 12. So then another thing to think about, this one's a little bit more subtle, is that if the diameter is 12 feet, then the radius is 6 feet. And what that tells us is the distance from here all the way to the top of the hemisphere of the top of the storage building. Okay, so this distance over here is 6 feet. So if the entire distance is 30 feet, we would do 30 minus 6 is 24, and that tells us that the height of the cylinder is 24 feet. Okay, so this is just for this part of the cylinder here. Okay, so this distance here is 24 feet. So now let's think about how we're going to find the volume of the storage building, which I'll put with a subscript s. Well, we're going to do pi times the radius squared times the height. This is the volume of the cylinder. And then we're going to add 4/3. Pi r cubed is the volume of a sphere, but we're finding the volume of a hemisphere. So we're going to divide this whole thing by 2. And now all we have to do here is just plug in. We have the volume of the storage building is equal to pi times the radius of the cylinder is equal to 6. So we have pi times 6 squared times the height. This was the part we had to really be careful here. The height of the cylinder is 24. And then we're going to add, we have 4/3. So I'll just draw a dividing line like this so we don't confuse these parts here with what we're plugging in. So we have plus 4/3 times pi, and the radius of the hemisphere is also 6 feet. So we have 6 to the 3rd power, and we're dividing all of this part, or all of this here, we're dividing by 2. So this we could just plug right into the calculator. So we have pi, and then we have 6 squared. So I have parentheses 6, and I square it, and we're multiplying this by 24, which I'll just do with parentheses. And then we have plus, and for this part, I highly recommend you press alpha, y equals enter. This will pull up a blank fraction, so you don't have to be as careful with your parentheses. So this is just a really nice thing to use. So we have 4/3. I'll write that in parentheses like this. And we're multiplying this by pi, and then we're multiplying that by 6 to the power 3. So I close the parentheses, and I press this up arrow here, and we write in R3. And we're dividing all of that by 2. Okay, so now we just press enter, and this is going to give us the total volume. So we're rounding to the nearest cubic foot. So we go to the ones place is a 6, to the right is a 7. So we're rounding up to 3167. So the volume of the storage building is going to be 3,167 cubic feet. Question 15, which regular polygon will carry onto itself after a 135-degree rotation about its center? So for this one, first we have to know that a regular polygon is a polygon with all sides equal in measure and all the angles are equal in measure. So if I'm talking about a triangle here, then I would be dealing with an equilateral triangle, because once again, a regular polygon, all of the sides are equal in measure and the angles are as well. So if I rotate an equilateral triangle about its center, then what I'm imagining is I have the center of the triangle, and I'm going to draw these dotted lines here going towards the vertices or the points of the triangle. And notice that I have a circle and I'm dividing it by 3 because a triangle has 3 vertices and it also has 3 sides. So 360 divided by 3 is 120. And that tells us that if I spin the triangle 120 degrees this way or the other way, it's going to map it onto itself. But I could also do 2 120-degree turns. So as long as I spin a multiple of 120, so I could do 120 degrees, I could do 240 degrees, or I could do 360 degrees, Or I could keep going here and go 480. It's going to carry the triangle onto itself. But we need to be able to spin 135 degrees to carry the figure onto itself. So the triangle is out. So basically what we're doing here is we're taking 360, we're dividing it by the number of sides. So next, for a pentagon, I divide by 5. And in this case here, I would get 360 divided by 5 is equal to, this works out to 72. And if I start counting by 72s, I'm going to have 72, and then I'm going to have 144, and I keep going here. So then if I add the next one, that would give us 216, and so on like this. And notice that 135 was skipped. So the pentagon is not going to be it either. So I'm looking for the shape that when I divide 360 by the number of sides, and I start listing the multiples of that number, that 135 is going to be in that list. So now let's see, we do the hexagon next. So we do 360 over 6 is equal to 60. And if I start counting by 60s, I get 60. And then next I get 120. And then I get, after this, 180. And notice that 135 is skipped. So this one is out. Oh, and also be mindful here that when I'm spinning the pentagon, I'm talking about 72 degrees, 144 degrees, and 216 degrees. So now, why is the octagon the solution? Well, if I take 360 and I divide it by 8, this division is going to work out here to, we're going to have 45. Okay, so 360 divided by 8 is 45. And if I count by 45s, I have 45 degrees. Then I have 90 degrees. And then I have 135 degrees. Okay, so if I spin an octagon 135 degrees, it's going to carry onto itself. So choice 4 is definitely our answer. Question 16, what is the length of the radius of the circle whose equation is, and we have this equation here. So for this one, what I want to do is I want to get the x terms together. So I'm going to rewrite this as x squared. I'm going to switch these two so that we have minus 2x. I'm going to leave a space, and then I'm going to write plus y squared plus 4y. And that minus 5, I'm just going to add 5 to both sides to move that constant over. So now I'm going to have a space here after minus 5 plus 5 cancels. And we're going to have this right side is equal to 5. Okay, so these terms here just cancel out. And now we're going to complete the square. And the way completing the square works is when we have a quadratic in the form of, let's say I focus on the x's first. When we have something like x squared plus bx, then what we do is we identify the b term, which in this case is negative 2. We divide that term by 2. So I'm going to think over here, we're going to have negative 2 divided by 2, and then we square it. Okay, so we take half of the b term and square it, and then we add that number to both sides. So we have negative 1 squared is 1. So I'm going to do plus 1 on both sides. So I'm going to add 1 to the left side, and that means I have to add 1 to the right side. And now I'm going to do a similar thing here. The b term for the y quadratic is 4. So I'm going to take 4, I'm going to divide it by 2 and square it. And that's going to give us 2 squared, which is 4. So now I'm going to add 4 to both sides. And now what we just did is we created 2 perfect square trinomials. So now we're going to factor. And to do this, we have to look for 2 numbers that have a sum of negative 2. And the 2 numbers have to have a product of positive 1. So if you think about the numbers, that's going to be negative 1 and negative 1. So we're going to have x minus 1 times x minus 1. And this works because negative 1 plus negative 1 is negative 2. And the product of negative 1 and negative 1 is positive 1. And now we're going to add, over here, we're looking for 2 numbers that have a sum of 4. And the 2 numbers also have to have a product of 4. And we think about this, we're going to have 2 and 2. So we're going to have, for this part here, we're going to have y plus 2 times y plus 2. And this works, once again, because 2 plus 2 is 4, and 2 times 2 is 4. And on the right side, we have 5 plus 1 plus 4, which is equal to 10. So now we could package this up. This is going to work out to x minus 1 squared, because we're multiplying matching binomials, plus y plus 2 squared, and this is all equal to 10. And in general, we have to know the formula for the equation of a circle. When we have a center of hk, so we have a center of hk, and we have a radius of r, the equation for a circle we could find by using x minus h squared plus y minus k squared is equal to r squared. So you could see now our formula, or our equation that we started with, is in the form it needs to be. So now we just match up the terms here. Notice that r squared is equal to 10. So we could say here that r squared is equal to 10, but we have to be very careful of choice 4. Choice 4 is a very dangerous bear trap. To find the value of r, we have to take the square root of this equation here. So we're going to have r is actually equal to the square root of 10. Okay, so choice 2 is going to be our answer. Question 17, the line represented by the equation y equals 4x plus 15 is dilated by a scale factor of 2 centered at the origin. Which equation represents its image? So for this question, it's very important that we know that dilated lines are parallel. Okay, so that's a real big idea for this question. So the idea behind that is when we have a center of dilation, let's say over here, and we have some line over here that's not on the center, so the line is away. If I pick out 2 points like this and I dilate them by a scale factor of 2, then the resulting line that I get should be parallel to the original one. So let's just see here. So this distance, I'm going to go out here and double it. So that's going to bring us out here. And I'm going to do the same thing for this one. It's going to bring us to about here. And now watch what happens when I connect these two. Notice that the resulting lines here are parallel. So what I'm going to say is that the line we're looking for is going to be parallel to y equals 4x plus 15. Okay, so it's going to be parallel to this line. So using that idea, now we're going to look at the equation y equals mx plus b. The slope is the m value, the coefficient of x, and the b value is the y-intercept. And we should know that parallel lines have the same slope. Okay, so parallel lines, we're going to say, have the same slope. So when we look at the answer choices, we're looking for an answer choice that has a slope of 4. So that's going to narrow down the answer or the correct answer to either choice 1 or choice 2. So these answer choices are out. And now notice that when our line is not on the center, we are going to get a different line when we dilate. So that means that the new line can't be the same line as the original here, because y equals 4x plus 15 is not at the origin. Okay, it's not going to pass through the origin. So that's how I know choice 1 is out and choice 2 has to be our answer. But let's see a way to really get this. So if I were to sketch this, y equals 4x plus 15, we have a y-intercept of 15. So the line is going to pass through the point over here. This is the point 0, 15. So let's just make this neater. We have 0, 15. And I'm just going to draw something like this. So this is just a sketch of the line. And the center is at the point 0, 0. So this is the center here of dilation. So when we dilate by a scale factor of 2, the easiest point to dilate is the y-intercept. So I'm going to dilate this point here, 0, 15. I'm dilating this by a scale factor of 2, and I'm centered at 0, 0. This is going to send us, when we dilate by a scale factor of 2, to the point 0, 30. All I'm doing is I'm multiplying 0 by 2 to get 0, and I'm multiplying 15 by 2 to get 30. And once again, just be mindful that the center of dilation is at 0, 0. Okay, so that's happening at 0, 0, and that's why we're landing here at 0, 30. So the new line is going to be at 0, 30, and it's going to be parallel to the original line. So when we draw in a line here connecting this stuff, we could see that the slopes are going to be the same. So we have a slope equal to 4, and we have a y-intercept equal to 30. So that's why we're getting y equals 4x plus 30. Question 18, line segment RH has endpoints r, -4, 4, and h, 2, -4. Which equation represents a line perpendicular to RH that passes through the point 3, -1? So for this one, the formula we're going to use is y minus y1 equals m times x minus x1. So our x1, y1 is the point that our line is going to pass through. So that's this point over here. So this is what we need. And notice that all of the answer choices use those x1, y1 coordinates. So we have y minus -1 becomes y plus 1, and then x minus 3. That's what all of the answer choices have in common. What makes them all different is the slope involved. So here, if we're talking about line segment RH with these endpoints, the first thing we should do is find the slope of line segment RH. And to do that, we're going to use the slope formula. So we're going to take the difference of the y values and divide by the difference of the x values. So I'll do -4 minus 4. So I'm subtracting this y value by this y value, and then I'm going to divide by 2 minus this x value is -4. And now we simplify, we have -8 divided by, this becomes 2 plus 4 on bottom, which is 6. And if we divide the top and bottom by 2, we get -4/3. But one thing that you have to know is that when you're looking for a line that is perpendicular to your original line, the slopes are opposite reciprocals. Okay, so when you're looking for the perpendicular line, the slope that you're going to use is going to be the opposite reciprocal. So here, if we have a negative slope, we're going to change it to positive, and we're going to flip the numerator and denominator. So we're finding, once again, look for the slopes are opposite reciprocals. So now we flip this, and this is going to become 3 over 4. I'll just make this a little bit neater. So we're getting 3 over 4. Just know when you're writing your slope and it's positive, you don't actually have to write a plus sign here. I'm just emphasizing that the sign is different than the original slope that we have. So that is the mystery slope that we need, and that only shows up for choice 1. So if we look over here, we could see that for choice 1, we have a slope in front of 3/4. So this is going to be our answer. Question 19, in right triangle SNO below, altitude NW is drawn to hypotenuse SO. Which statement is not always true? So for this one, we have to know that when we have a right triangle and an altitude is drawn to the right angle like this, we get 3 similar triangles. Okay, so I could say that triangle SWN is similar to triangle NWO, and that's going to be similar to triangle SNO. But what I like to do for questions like this is separate the triangles and draw them so that they are all facing the same direction. So this really helps if you understand the concept of transformations. You could see these triangles being dragged out and rotated, but they would all be facing the same direction if I wrote them like this. So now I think it'll make it much easier to go through the answer choices to see which one is not always true. So if we do SO over SN, so that's in the big triangle. SO is over here at the hypotenuse, and SN is the vertical side. So we have SO over SN, and let's see, equals SN over SW. Well, notice what we're comparing here. We're comparing this side, so SO over SN. We're comparing that to SN over SW. And notice those sides are corresponding, so these ratios here we can say are equal. So choice 1 is out. This equation will always be true. Next, we have SW over NS. So I see here now SW over NS is comparing the sides in this small triangle. So we have the vertical side that I have drawn here over the hypotenuse, and we want to ask ourselves, is that always equal to NS over OW? Well, if we look here, NS is part of the big triangle, and OW is part of the medium triangle. So this one here is looking a little bit funky. Okay, I don't like this statement here because it's bouncing around between 2 different triangles. If we look once more, SW over NS, and now we're looking at NS, and then looking at OW. You see how we're going from the small to the medium triangle here. So this one is not looking good. I want to say this one is not always true. But to be 100% sure, I'm going to go through the other answer choices and see that they're always true. So now we're looking at SO over ON. So that's the big triangle. SO over ON is looking at the bottom side here. So hypotenuse to the bottom side. And now ON and OW is the medium triangle. So we have NO over OW is the hypotenuse to the bottom side. So these ratios here are going to be equal. So I'm going to chop this one off. And now for the last answer choice, we have OW over NW. So that's the medium triangle. OW over NW equals NW over SW. So this works because we're comparing the bottom side, the horizontal leg to the vertical leg is going to be equal to the ratio of the horizontal leg to the vertical leg in this triangle here. So this one here is definitely always true. So it's going to be choice 2. Question 20, a rectangle has a width of 3 and a length of 4. The rectangle is dilated by a scale factor of 1.8. What is the area of its image to the nearest tenth? So for this one here, what we could do is we could draw out a rectangle. So we have some rectangle. The dimensions are 3 by 4. And we're going to dilate this rectangle by a scale factor of 1.8. So what we're going to do is we're going to multiply the length and the width by 1.8. And if we do that, we're going to get, I'll write it over here, we're going to have a new width of 3 times 1.8 is 5.4. And the new length is 4 times 1.8, which is 7.2. And what we could do is find the area of this new rectangle. The area of a rectangle is length times width. So we just plug in, and we're going to have area equals 7.2 times 5.4. And if we work this out, 7.2 times 5.4 is going to give us 38.88. So the area is equal to 38.88, and we're rounding to the nearest tenth. So we look out to the tenths place is an 8, and to the right is an 8, which is 5 or higher. So we're going to round this up to 38.9. Okay, so choice 4 is our answer. For this question, though, we do have to be very careful. It is tempting to just do the area of the original rectangle is 3 times 4, which is equal to 12, and students will just take the 12 and multiply it by 1.8. And if you multiply 12 by 1.8, you're going to get 21.6. And choice 3 is waiting for you, but choice 3 is a very dangerous bear trap. Okay, for this, you have to be very, very careful. The reason why this method doesn't work is because area is a two-dimensional measurement. Okay, so you can't just multiply by the scale factor. You would have to multiply by the scale factor squared. So we would take the old area 12 and we would multiply it by 1.8 squared, because not only is the length getting scaled by 1.8, but the width is getting scaled by 1.8 as well. So that's why we have to square the scale factor. If we were talking about volume and we're talking about scaling a 3D shape, then we would have to multiply by the scale factor to the third power. Okay, and if you do this in a calculator, 12 times 1.8 squared, this is also going to give you 38.88, which is going to give you the same answer choice 4. Question 21, in the diagram below of circle P, diameter MD and chord AL intersect at Q, and the measure of angle AQD is 46 degrees, and the measure of arc LD is 124 degrees. And we want to know what is the measure of arc AD. Okay, so we're looking for the measure of this arc over here. So for this one, we have to know that when we have intersecting chords, that the angle formed over here is equal to the average of the chords. So what I could say is the measure of arc ML, so the measure of arc ML plus the measure of arc AD divided by 2 is equal to this angle here, which is 46 degrees. And I know the angle is 46 degrees because when we have intersecting lines or chords, the vertical angles formed are congruent. Okay, so this is once again true if we have intersecting chords, or if we're out of a circle, we have intersecting lines or intersecting line segments or rays, the vertical angles, the ones across from each other, are congruent. Okay, so that's how I know this angle here is also 46, and we could use this formula. So we know over here the measure of arc LD. So to find the measure of arc ML, we're going to use the idea that when we have a diameter, the diameter cuts the circle in half. So this entire space here is 180 degrees. So all I have to do is 180 degrees minus 124 degrees. So we work this out. We could just subtract. I'll do it by hand, but I'm going to borrow here 7, carry this 1 over here. 10 minus 4 is 6. 7 minus 2 is 5. So the measure of this arc is 56 degrees. So we could label that arc 56 degrees. We have the measure of arc ML is 56 degrees, plus the measure of arc AD divided by 2 is equal to 46 degrees. And now to solve for the measure of the arc, we're going to call this 46 degrees over 1 and cross multiply. So now we have 56 degrees plus the measure of arc AD times 1 is just 56 degrees plus the measure of arc AD. And this is equal to 46 degrees times 2, which is 92 degrees. And now we just solve by subtracting 56 degrees on both sides. And on the left side, all we're left with is the measure of arc AD. And on the right side, we could type this in a calculator. We'll get 36 degrees. So the correct answer here is choice 1. Question 22, the right prism with a triangular base shown below is cut by a plane perpendicular to its bases. The two-dimensional shape of the cross-section is always and we have these options to choose from. So this is the most important part over here. We have to read this very carefully. The figure shown below is cut by a plane perpendicular to its bases. The bases are over here. So this is a base over here, and this is a base over here. When I hear base, I just think bottom, and that's the part that's resting if this were on the ground. So if we're going perpendicular to the base, and the base is facing this horizontal direction, then our plane is coming in at a vertical direction here. Okay, so the plane that we're going to draw, so I'll erase this phrase now, is going to be vertical. So let's just get this out of here. So now we're going to be looking at this plane coming in like this. So no matter which way I draw it, it's going to make 4 points of contact, so it's going to form a rectangle. if I were to draw the plane, let's say coming in this way, let's say it's chopping through the figure like this, then I would have another rectangle. Okay, it's going to make 4 points of contact and form a rectangle. If we had gone in parallel to the bases, so let's say instead of perpendicular, it said parallel, then we would be cutting this shape horizontally. Okay, so I'm just going to cut this horizontally and imagine what shape would I be looking at. So when I draw my plane this way, as it comes in, it's going to make 3 points of contact in the figure, and it's going to form a triangle. But we are not cutting this parallel, we're cutting it perpendicular. So that's why our cross section is going to be a rectangle. Question 23, a rectangular fish tank measures 24 inches long, 12 inches wide, and 16 inches high as modeled in the diagram below. If the empty tank weighs 25 pounds and the fish tank is filled with water to a height of 14 inches, what is the approximate weight of the tank and water? And we have this unit measurement over here, 27.7 cubic inches is equal to 1 pound of water. So for this one, we have to be very careful. We have to make sure that we model the water at a height that's not equal to the height of the entire tank. Okay, the height of water is going to go up to 14 inches. So that's very important here, because sometimes if you go through these questions quickly, you'll just use the dimensions they give you. But we have to chop off, some of the height off the top here. We're only going to go up to 14 inches. So when we find the volume of water is going to be the formula for the volume of a rectangular prism, and we're doing the length times width times height. But for the length, we're going to use 24 inches. For the width, we're going to use 12 inches. And for the height, we're going to use 14 inches. Okay, so we're going to multiply these three values together here. And just know for the regions, you don't actually have to write units in. I just like to write units for these questions so that you could see how the units cancel out and give us the correct answer. So we multiply this out. 24 times 12 times 14 is 4,032. And when we do inches times inches times inches, that's cubic inches, or I write it out as inches to the third power. So from here, now that we have the volume of water, we could find the weight of the water. Okay, so this is going to tell us now the weight of the water. And I like to write units in the question here because it's nice to see how the units cancel out and bring us to the correct answer. So we have 4,032 cubic inches of water. And if 1 pound of water is equal to 27.7 cubic inches, we could multiply by this conversion factor. 1 pound of water is equal to 27.7 cubic inches. So I'm going to multiply by 1 pound over 27.7 cubic inches. And this is valid because these two things are equal. And so with the units attached, I'm really just multiplying by 1 because I have a fraction where I have one equal quantity over another equal quantity. So here the units now cancel out, and we just do 4,032 divided by 27.7. So we work this out, and this will come out to 145 point, and we'll have 559, and then we have 56. So I'm just going to round this up to a 6. Okay, since we're going to be rounding at the end to the nearest whole number for the approximate weight, I don't need to go that far out. But we have to be careful here. It's very tempting to just choose choice 1. But choice 1 is a very dangerous bear trap. They're asking us for the approximate weight of the tank and the water. So we also have to take this value here and do plus 25. So we're going to have here 140. I'm going to round this up to 146 because we're rounding to the nearest whole number. 146 plus the weight of the tank weighs 25 pounds. Okay, the empty tank is 25 pounds. And when we work this out, this is going to work out to 171. So the correct answer here is choice 3. Question 24, a circle has a radius of 4.5. What is the measure of the central angle that intercepts an arc whose length is 6.2 to the nearest degree? So for this one, we have a circle, and the radius of the circle is 4.5. So that's the distance from the center to any point on the circle. And what we're looking for is the measure of the central angle that intercepts an arc of length 6.2. So for this one, I'm just imagining the arc is on the outside. So let's say it were to go up to this distance. We don't know what the actual angle is, but let's say it's about here. Then what we're looking for here is the measure of the angle in the center. The arc on the outside is 6.2 units long. So to find this, what we are going to do is we're going to find the entire distance going all the way around. and the circumference, the entire distance going around, is 2 pi r. So if I plug in circumference equals 2 times pi times r is 4.5. So we work this out. 2 times 4.5 is equal to 9. So the circumference is 9 pi. This is the whole distance around, okay, going all the way around. So the concept that we need, what I think of for these questions, is part over whole. Okay, we're taking a fraction of the circle. We're doing part over whole. And the part of the circle that we're looking at is 6.2. Okay, we're taking this part of the circumference, and the whole circumference is 9 pi. And what we want to do is we're going to take this fraction and we're going to multiply it by the total degree measure of a circle is 360 degrees. Okay, so we're taking the part over the whole, and that's going to give us the fraction we need to multiply by 360 to tell us the measure of this angle here at this, at this portion of the circle. Now, one thing to be very careful of, when you write 6.2 divided by 9 pi, please don't do something like this. Don't do 6.2 divided by 9 pi. Pi is second and the up arrow. If we do this, it's a very dangerous bear trap, okay? If you are going to do it this way, you have to make sure that you put 9 pi in parentheses. It's going to give you something different, okay? The problem with this method over here is it's doing 6.2 divided by 9 and then multiplying by pi. So another way around this is to do alpha y equals enter. And here you could write 6.2 and the 9 pi on bottom. And if we do this, notice it's going to give us the correct one, the 0.219. So this is the one we want. And we're going to multiply that by 360. And this is going to give us our angle. So we're taking this product to the nearest whole number. So we look at the ones place is an 8, to the right is a 9. So we're going to round up to 79 degrees. So that's the measure of our central angle here. And this matches up with choice 4. So now we're moving on to the part 2 questions. There's 7 questions here, and each one is worth 2 credits. Question 25, in the diagram below, triangle SUV is similar to triangle TRE. If SU equals 5, UV equals 7, TR equals 14, and TE equals 21, determine and state the length of SV. So for this one, what we're going to do is set up a proportion because we have similar triangles. And in similar triangles, the corresponding sides are in proportion. So here in this triangle, I'm going to say 5 over x first. I'm comparing the left side to the right side. So in this triangle, I could say that this ratio is equal to 14 over 21. And the big idea for these questions is that whatever ratio you set up, you have to make sure that you're consistent in the next triangles. So if I'm comparing left side over right side, then I have to set up left side over right side in the next triangle. And now from here, I could just solve for x. So I'm going to do cross multiplication here. So I'm going to do 14 times x is 14x. And then I have 21 times 5, and that gives us 105. And then from here, we just divide both sides by 14. And on the left side, 14 over 14 cancels. And now we could just do the division. 105 divided by 14, we could just type that in a calculator. We're going to get 7.5. And this represents the length of SV. So I'm just going to say at the end that SV is equal to 7.5. And here's our solution. Question 26, using a compass and straight edge, construct a line of reflection that maps triangle ABC onto its image triangle DEF. And we have to leave all construction marks. So for this one here, if we're constructing a line of reflection, let's say I'm focusing on point C and point F. F is the image of point C after that reflection. So I would have to construct the perpendicular bisector of CF, because you could just imagine here, this mirror line would go right down the center, cutting CF in half and forming a 90-degree angle. So we're going to construct the perpendicular bisector of CF. So what I'm going to do is I have to open the compass to more than halfway. I'm going to swing an arc above like this, and I'm going to swing an arc below. So I'm going to swing above and below, and then I'm going to move from point C to its image at point F. I'm going to flip the compass. I'm not going to change the length. I'm going to swing an arc above and below, and I have 2 points of intersection when my arcs intersect. And now all I have to do is connect. For question 26, this is all we need to put on our paper to get full credit. Question 27, we have triangle max has vertices with these coordinates here, and we need to determine and state the area of triangle max. They tell us the use of the set of axes below is optional, but I definitely want to draw this out. So once we have the points plotted and the triangle drawn, what I like to do is draw a rectangle in such a way that it encloses the triangle as much as possible. So it's the smallest possible rectangle that I could draw that contains all 3 points. Okay, so I'm drawing the rectangle in such a way that it hits all 3 points of the triangle. And from here, what we could do is count the boxes going across and going down. Okay, so count the boxes going this way and this way. Now, you could also just use subtraction. Like, notice going from left to right, I'm going from M all the way over to the X coordinate for point X. And if I look at M and X, the difference in the X values, 4 minus -5 is 9. So I could use subtraction, or I could count the boxes. I could go 1, 2, 3, 4, 5, 6, 7, 8, 9. So either way, I'm going to get the same thing. And then going up, I'm going up 1, 2, 3, 4, 5, 6. So the area of the rectangle over here, we would just do 6 times 9. Okay, so I could say 6 times 9. This is going to give us the area of the rectangle. But our goal is to find the area of the triangle. So then what I want to do is I want to subtract the area of the rectangle minus the area of these 3 right triangles. So I have a right triangle here. So this is 1. I have another right triangle over here. This is our second right triangle. And then we have a third right triangle over here. So I have to find the dimensions of these individual right triangles. So we have that this side over here is 6. But then this one is 1, 2, 3, 4, 5, 6. Okay, so this one here is a 6 by 6. I'll just make it a little neater. So we have a 6 by 6. And then over here we have 1, 2, 3, which makes sense because 6 plus 3 will give us 9. And then over here, this is going 1, 2, 3. So this triangle over here is a 3 by 3 right triangle. And then going up, we're going up 1, 2, 3. So now we have the dimensions. So the next thing to know is that the area of a triangle is equal to 1/2 base times height. And notice that we have 3 right triangles here. So the base and height, we could just say, are these side lengths over here that we counted out. So now I'm going to subtract this sum over here. So we have 1/2 times, and we'll talk about the first triangle. I'm subtracting out the area of the first triangle. So I'm doing 1/2 times 6 times 6. And then next we have 1/2 times, and then we have a 3 by 3 here. So 3 times 3. And then after this, the last triangle that I'm subtracting out is the 1/2, and then we're multiplying by the base and height of 9 and 3. So I'm doing 1/2 times 9 times 3. And this, I could just type all of it in a calculator. So I'm doing 6 times 9 minus, and then here I have to write parentheses. For 1/2, I could say 1/2, or I could say 0.5. And I'm multiplying by 6 times 6. And then I'm going to add, we have 0.5, that's equal to 1/2 times 3 times 3. And then one more, we have plus 0.5 times 9 times 3. Okay, so I'm just going to work this one out as well. And then I close the parentheses, I press enter, and this all works out to 18. So this all works out to 18, and I'm just going to say that this over here is the area of triangle max. Okay, so this is what we just found, the area of triangle MAX. Question 28, a person observes a kite at an angle of elevation of 32 degrees from a line of sight that begins 4 feet above the ground, as modeled in the diagram below. At the moment of observation, the kite is 70 feet above the ground, and we need to determine and state the horizontal distance x between the person and the point on the ground directly below the kite to the nearest foot. So for this one here, we just have to be very careful of what's going on in the diagram. So they're telling us that this distance here is 4 feet. So I'm just going to say that this distance over here is equal to 4 feet. And notice that the entire distance up to the kite is 70 feet. So we need to do 70 minus 4, which is 66. So this right triangle over here, what we're looking at, I'm just going to draw it separate, is we have a right triangle, and we have this side over here is x. This angle is 32 degrees, but the vertical leg is 66 feet. Okay, so over here, this is 66 feet. It's very important that we subtract the 4 like this, because once again, it's starting from a line of sight that is 4 feet above the ground. So we have to take that into account. And now think about this angle here. It is pointing towards this side, which is the side opposite of the 32 degree angle. So this side here is opposite, and the one next to the 32 degree angle over here, this leg, is the adjacent side. And across from the right angle is always the hypotenuse. So when we have to choose a trig function here, we're thinking of the mnemonic SOHCAHTOA. So SOHCAHTOA. And we think about the phrase opposite adjacent, and that tells us to select the tangent function. Okay, so we're going to do tangent of the angle is 32 degrees equals the ratio of the side opposite, which is 66 feet. But I'm going to leave the units out for now. I'll write the units at the end. So we have 66 over x. And now from here, we just do the algebra. So we could call this tan 32 over 1, tangent of 32 degrees, and we cross multiply. So we have x times tangent of 32 degrees is equal to 66 times 1 is 66. And then from here, our goal is to solve for x. So we just divide both sides by tangent of 32. Okay, so we have divide by tangent of 32 degrees. And these terms cancel, and the rest we just type in the calculator. So we're doing 66 divided by tangent of 32 degrees. We press enter, and we get this value here. So our x value here is 105.622. And the question told us to round to the nearest foot. So here we go to the ones place is a 5. To the right is a 6. So we would round up to 106. And the units here are feet. So the horizontal distance is 106 feet. Question 29, in triangle AGL, N and E are midpoints of AG and AL respectively. NE is drawn. NE equals 15. GL equals 3x minus 12. And we need to determine and state the value of x. Well, one thing they told us was N and E are midpoints. So I could say that this line segment and this line segment are the same. And I could say that these two line segments are the same. So there's a special name for this line segment over here. NE is actually called the midsegment. Okay, so this is the midsegment, and a special property of midsegments is that they are parallel to the third side and they are half as long. Okay, so when we connect two midpoints of two sides of a triangle, the midsegment, we call it, is parallel to the third side and half as long. So that allows us to set up the equation. I'm just going to write this a little bit neater. We have 3x minus 12 is equal to 2 times 15, okay? Because if this piece is half of this piece, if I double this, I'm going to get this length over here. So now we have 3x minus 12 is equal to 30. And then we add 12 to both sides and just do the rest of the algebra. So we have 3x minus 12 plus 12 cancels, and this is equal to 42. And now from here to solve for x, we're just going to divide. So we divide both sides by 3, and this is going to give us x is equal to 14. Question 30, in the diagram below, triangle tan is the image of triangle sun after a reflection over ray NZ. And then we need to use the properties of rigid motions to explain why triangle tan is congruent to triangle sun. So they're telling us here that triangle tan is the image. So this is the one that's happening after the transformation. So we are taking this triangle, reflecting it over this ray, and it's bringing us onto this one. Now, one thing to know is that a reflection is a rigid motion. So what we have is a reflection is a rigid motion, and a rigid motion is a transformation that preserves distance and angle measure. So what that means is that when we reflect, this side length over here, so let's say SN, is going to be congruent to TN. And then we have this side over here, SU, is going to map onto this one over here at TA. These two sides are going to be congruent. And then the last side here, UN, is going to map onto AN and making these pairs of sides here congruent as well. So these triangles are going to be congruent. I could say SSS, but this is only a 2-point question, so I don't have to write as much. What I have to mention in my response is that a reflection is a rigid motion which preserves side lengths and angle measure, and that makes the two triangles congruent. Now, the key phrases that I mention here are we have a reflection, which is a rigid motion, and a rigid motion preserves side lengths and angle measures. So that's why these two triangles are congruent. The side lengths and the angles do not change. Question 31, a pyramid with a square base is made of solid glass. The pyramid has a base with a side length of 5.7 centimeters and a height of 7 centimeters. The density of the glass is 2.4 grams per cubic centimeter, and we need to determine and state to the nearest gram the mass of the pyramid. So for this one, we have a pyramid, And the pyramid has a square base. So I'm just going to draw this out. So here is our pyramid, and the base is a square. So this is the pyramid, and we're told that the side length of the base is 5.7 centimeters. So all the way around, we have 5.7 centimeters. And the height of the pyramid is 7 centimeters. So going from the top to the center of the square base, that distance is 7 centimeters. Now, we have to know that the volume of a pyramid is 1/3 times capital B times H. This formula is in the back of the Regents, and they define each piece for you. Capital B is the area of the base. Okay, so this is the important thing that we have to find. So since the base is a square, we're going to do volume equals 1/3 times capital B, we're doing 5.7 centimeters times 5.7 centimeters. And then we're multiplying the area of the base times the height, which is 7 centimeters. So we're doing this and then times 7 centimeters. So we're doing 1/3, so we have 1 divided by 3, and I'll throw this in parentheses. And we're multiplying by 5.7 times 5.7. And then next, we are multiplying by 7. So I'm just going to put parentheses 7 and close it, and this gives us the volume. So the volume is 75.81, and the units here, we're doing centimeters times centimeters times centimeters, which is cubic centimeters. So I have centimeters to the 3rd power. Now, for these questions, you do not have to write units, but the reason why I like to write units is I think it makes it obvious what to do with the density. So density, we should know, is mass over volume. So if I want to find the mass, I just cross multiply here, and I'm going to have m times 1 is capital M, and that gives us density times volume. So this is how we're going to find the mass. But when we write the units in, I think it makes it more obvious how to find the mass. So here, we're going to say the mass is equal to, we have the volume is 75.81 cubic centimeters. And we multiply by the density, which is 2.4 grams per cubic centimeter. So I'm writing grams over cubic centimeters, and notice that the units cancel out. Okay, these terms cancel, and we're left with just grams. So the mass, now all I have to do is 75.81 times 2.4. So this works out to 181.944 grams, but we are rounding to the nearest gram. So we look here in the ones place, we have a 1. To the right is a 9, so we round up to 182. So we could say 182 grams. This is the rounded answer, so I'll box this one off. Question 32, a drone is used to measure the size of a brush fire on the ground. Segment AB represents the width of the fire as shown below, and the drone calculates the distance to point B to be 1,076 feet at an angle of depression of 25 degrees. At the same point, the drone calculates the distance to point A to be 774 feet at an angle of depression of 36 degrees. And we need to determine and state the width of the fire AB to the nearest foot. So here we have this 36 degree angle over here. And this line drawn in is parallel to this line here. So I could say we have alternate interior angles. So if this angle here is 36 degrees, so is this angle over here. We have a 36 degree angle over here, and I'll just make this a little bit neater. So we have 36 degrees going this way. So we have a right triangle, and this is a 36 degree angle over here. And now this little angle is 25 degrees. So if I have this alternate interior angle over here, I could say that this one is equal to 25 degrees. So now what I want to do is I want to label this distance from here to here X, and this one over here Y. And I'm going to split this diagram up into 2 triangles. So I have the small right triangle is X over here, 36 degrees, and 774 feet. And then the big right triangle, the bottom space is going to be X plus Y. So going from here to here is X plus Y. This angle is 25 degrees, and this hypotenuse is 1,076 feet. So from here, we're going to find the length of AB, and that's going to be the variable Y. So I'm going to set up 2 trig equations now. So for this one, I'm going to do cosine of 36 degrees. So we have cosine of 36 degrees is going to be equal to the ratio of the side adjacent to the 36 degree angle X over the hypotenuse is 774. And now in this triangle, I could say cosine of 25 degrees is equal to the ratio of the side adjacent, which is x plus y, over the hypotenuse, which is 1076. So from here, what I'm going to do is I'm going to solve for x, and I'm going to solve for x plus y. So I'm just going to put these over 1 and cross multiply. So x times 1 is x, and that's going to equal 774 times cosine of 36 degrees. And then I cross multiply here, and this gives us x plus y is equal to 1076 times cosine of 25 degrees. And then our goal is ultimately to find the length of AB. So I'm going to solve for y. So for this one, I'm going to do minus x on both sides. So I'm going to go minus x. And in the next line here, what we're going to have x minus x canceling. And we're going to have y equals 1076 cosine of 25 degrees, and then minus x. So then the last bit of algebra that we're going to do is we're going to make a substitution. I'm going to say y is equal to 1076 times cosine of 25 degrees minus x, and x is equal to 774 times cosine of 36 degrees. So we have 1076 times cosine of 25, and we're subtracting 774 times cosine of 36. And we press enter, and this gives us the value we need. Now for this one, we have to round to the nearest foot, and notice in the ones place we have a 9, to the right is a 0, so we're rounding down to 349. So we could say that the width of AB to the nearest foot is 349 feet, and this is our solution. Question 33, quadrilateral ABCD has vertices with these coordinates here. Joe defines an isosceles trapezoid as a trapezoid with congruent diagonals. Use Joe's definition to prove ABCD is an isosceles trapezoid. So for this one, the use of the set of axes below is optional, but I'm definitely going to use them. So now that we have this drawn out, first we're going to show that we have a trapezoid, and we'll do that by showing that we have one pair of opposite sides that are parallel. So we're going to target sides AB and DC because it's clear here that these are the sides that are parallel. That's why it's nice to actually use the set of axes below. So we're going to find the slope of line segment AB. So for this one, I could use the slope formula. So for the slope formula, just know that slope is y2 minus y1 over x2 minus x1. I could just do the rise over run, or I could use the formula. So I have 3 minus 6. I'm doing the difference of the y values, and I'm going to divide by the difference of the x values. So I have 6 minus negative 3. And this gives us 3 minus 6 is negative 3 over 6 minus negative 3 is 9. And this fraction reduces to negative 1/3. Now for this one, if reducing fractions is a little tricky for you, you could do negative 3 over 9. Press enter and then press math, enter, enter, and that'll turn your answer into a simplified fraction. So now I'm going to find the slope of this line segment over here. I'm going to find the slope of line segment DC. So for this one, I find the slope between these 2 points, and I'm going to do the difference of the y values. So I have 2 minus negative 2, and I'm dividing by the difference of the x values. I have negative 6 and then minus 6. And this gives us 4 on top. I have 2 minus negative 2 becomes 2 plus 2. Over negative 6 minus 6 is negative 12. And if I reduce this fraction, I divide the top and bottom by 4, I also get negative 1/3. And notice that I have equal slopes. So since these slopes here are equal, that means that the line segments here are parallel. Okay, so these being equal allows us to say that line segment AB is parallel to line segment DC. Okay, I like to use this flowchart way of explaining so that I don't have to write out too much, because notice we don't have a ton of space here. So this statement here is very big. This allows us to say that ABCD is a trapezoid. But now we're going to use Joe's definition here. We're going to target the diagonals. We're going to find the length of those line segments. So here I'm going to find the length of diagonal AC. And for this one, I could use the graph. I could count the rise over run. So we're going down 1, 2, 3, 4, 5, 6. And then we have 7, 8. Okay, so we're going down 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going down 8 over 9. So what I do is I draw a right triangle on the side, and this side here is 8 units long, and this one is 9 units long. So if this is the length of AC, now I could use the Pythagorean theorem to find the length of AC. So I could say that the hypotenuse is AC. So from here to here is AC. So I have AC squared is equal to 8 squared plus 9 squared. And for this, we have AC squared is equal to, I have 64 plus 81. And now we work this out. We have AC squared is equal to 145. So I take the square root of both sides, and that tells us that AC is equal to square root of 145. Okay, so this is the triangle that we're going to use, but I could just say here that AC is equal to the square root of this part here, the 64 plus 81. So this is really what's going on. I'm taking the square root of this, so I could just say the square root of 64 plus 81 like this, and show the work over here in this space. I only showed all of these steps just in case the Pythagorean theorem is a little tricky for you, especially when you have to use it when you're applying it to two letters like this. If you're naming the side length as AC, it can be a little tricky to see it like this, but we're just building a right triangle on the graph. Now, if you could remember the distance formula, you can absolutely use the distance formula here, but this formula could be a little bit tricky to remember. So I always show my students how to draw the right triangle on the picture. That way you could just use Pythagorean theorem. So that's for the length of AC. Now for the other diagonal, BD, so we have BD is equal to, I'm going to do the rise over run again. So we're going to go, in this case, maybe I'll go over first and then up. I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going over 12 and I'm going up 1. So this right triangle over here for BD is looking something like this. We have B here and D here. This distance over here is 12. This one is 1. So now I could say BD squared is equal to 12 squared plus 1 squared. So BD squared is equal to 144 and then plus 1, which is going to give us 145. So BD, I could say, is the square root of 144 plus 1, and this simplifies to the square root of 145. Okay, all I would do here is just take the square root of both sides like this, and that's where we're getting BD equals. But one thing to comment on, notice that these two values here are equal. So what does this tell us? It tells us that AC is congruent to BD. Okay, so once again, I like to use the flow chart because otherwise I have to write a sentence. I would have to say, since AC and BD are equal in measure, AC is congruent to BD. So this flow chart makes it way nicer. And now I just have to summarize everything. So first we could say that ABCD is a trapezoid because one pair of opposite sides are parallel. And now we could write our last sentence. We showed that the diagonals were congruent. So now we could use Joe's definition here and say that since we have a trapezoid with congruent diagonals, our trapezoid is isosceles. So notice here I am mentioning that ABCD has congruent diagonals. Therefore, ABCD is an isosceles trapezoid. If you're not familiar with this notation, just know the 3 dots says the same thing as therefore. Question 34, Ali made 6 solid spherical decorations out of modeling clay. Each decoration has a radius of 2.5 inches, and the weight of the clay is 68 pounds per cubic foot. And we need to determine and state to the nearest pound the total weight of the 6 decorations. So for this one, I'm just going to draw out a sphere, and we have the radius of the sphere is 2.5 inches. So I'm just going to label on the inside. The radius is 2.5 inches. And what we want to find is the weight of the 6 decorations. So first what we're going to do is we're going to find the volume of one. So the volume of a sphere is 4/3 pi r cubed. So here we just have to plug in the radius. We have 4/3 pi times the radius is 2.5 inches. And this we're raising to the 3rd power. So we're going to do 4/3. So I write 4/3 in parentheses. And then we have times pi is second and the up arrow. And then we're multiplying that by 2.5 to the 3rd power. Okay, we press enter. And this gives us the volume of one sphere. So the volume is equal to, we have 65 and we have this decimal here. Okay, and the units are cubic inches. We have inches to the 3rd power. So the units are going to be cubic inches. And what we have to do is find the total weight of 6 decorations. So we're going to have 6 of these. So at some point, we're going to have to multiply by 6. But one thing I want to pay attention to is that the weight of the clay is in terms of pounds per cubic foot. So one thing I want to make note of is that 1 foot is equal to 12 inches. So notice we found the volume in cubic inches, not cubic feet. So what we could do is we could take this equation and we could raise both sides to the third power. And what this tells us is that 1 cubic foot is equal to 1728, and then we have inches to the third power, which is cubic inches. So the reason why I'm writing this out is that when we want to find the total weight of 6 decorations, we could say the total weight is equal to, and now we could start multiplying. So we have 6 times the volume is 65 point, and we have this decimal over here, so 449, and then 84695 cubic inches. But when I multiply by the density, which was, we said over here, 68 pounds per cubic foot, I'm not going to write 68 pounds per cubic foot. I'm going to replace cubic foot with 1728 cubic inches, because cubic feet is equal to this measurement here. 1 cubic foot equals 1,728 cubic inches. So I am just making that substitution, and the reason I do that is so the units actually cancel out here. Okay, that's a very important detail. So now we multiply, we have 6 times, and I'm going to press the up arrow and press enter to type in what we had from before, and we're multiplying by the fraction. We have 68 over 1,728. And now we press enter, and here's our solution. So this works out to 15.4534. I'll stop here, and the units are pounds, but the question told us to round to the nearest pound. Okay, so we're rounding to the nearest whole number. So we go back to this work over here to the nearest whole number. We look over here at the 5 in the ones place. To the right is a 4. We are rounding down to 15 pounds. So here is our solution. So now we're moving on to part 4, the final boss, and this question is worth 6 credits. Question 35, in quadrilateral hope below, EH is congruent to OP. We have EP, this side over here, this entire side, is congruent to OH. So these two sides are congruent. And then we have EJ, so this segment over here, is congruent to OG. And then we have TG and YJ are perpendicular to diagonal EO at points G and J respectively. So we could say that this angle and this angle are both 90 degrees. They're both right angles. And what we need to do is we need to prove that TG is congruent to YJ. Okay, we're proving that TG is congruent to YJ. Now, the first thing that we have to do is write down the givens. This is something that has to be a part of our answer. Now, writing the givens is something that we have to do. It does take a while, but it needs to be there because it allows us to say the things that we want to say after this. So now for statement 2, I'm looking at this diagram, and I notice that both pairs of opposite sides of quadrilateral hope are congruent. So we could say that quadrilateral hope, and I'll abbreviate, I'll just say quad hope, is a parallelogram. And let's make this a little bit neater. So we have quad hope is a parallelogram. And we know that quad hope is a parallelogram because both pairs of opposite sides are congruent. Now, once we know we have a parallelogram here, we could say things like alternate interior angles are congruent. So I look for that Z shape, and that tells me that this angle here is congruent to this angle. But one thing we have to be very, 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 very careful of. We actually have to make the statement first that these two line segments are parallel, because we cannot say alternate interior angles until we establish that we have a pair of parallel lines. Now that we establish that the opposite sides here are parallel, we can now say that the alternate interior angles formed here are congruent. Now, if you struggle to name an angle with 3 letters, you are allowed to introduce numbers. So I could put a 1 here and a 2 here, and I'm allowed to say that angle 1 is congruent to angle 2. And the reason is that when parallel lines are cut by a transversal, the alternate interior angles formed are congruent. So next we could target these line segments over here, EG and OJ. So in the beginning, we were told that EJ, that's the distance from here all the way to here, this segment is congruent to OG, which is going all the way from here to here. And notice that these line segments that I just highlighted in pink overlap at GJ. So I'm going to use the subtraction postulate next. I'm going to say first, even though this is very obvious, I'm going to say that GJ is congruent to itself. So GJ is congruent to GJ because of the reflexive property. So now for the next statement, I'm going to say this. I'm going to say EJ, so we have EJ minus GJ is congruent to, and we have OG is the entire segment over here. So we have OG and then minus GJ. And I just want to point out here, if we have this entire segment EJ and we subtract out this part, that leaves us with EG. So we have EG is congruent to, and I'll make this a little neater. So we have EG is congruent to, and then when we do OG minus GJ, if we subtract this piece out, we're left with OJ. So we're left with OJ. So we could say that these two line segments are congruent. And for this one, we use the subtraction postulate. Okay, so we use the subtraction postulate. And one thing I want to point out, the statement in statement 5, even though it seems very obvious, in order to use the subtraction postulate, you have to say that the entire piece and the small piece that you're subtracting is congruent to the entire piece over here and the small piece that we're subtracting. Okay, that's a very important statement. Notice in the beginning, we said that EJ was congruent to OG, and then in this statement, we said GJ is congruent to itself. So when I do EJ minus GJ is congruent to OG minus GJ, I'm ready to go because I already made two statements of congruence before. And remember, the subtraction postulate says when congruent segments are subtracted from congruent segments, the differences are congruent. So statement 6 is valid. So what we just established is that we have a pair of sides congruent in both triangles, and we already established that we have a pair of congruent angles. So the last thing we're going to do is establish another pair of angles as congruent. So I'm going to call this right angle over here. I'm going to put a 3 here, and that's going to be angle 3, and this is going to be angle 4. So the next thing I want to do is establish that we have right angles. For statement 7, we know angle 3 and angle 4 are right angles because perpendicular lines form right angles. We said that over here. We said TG and YJ are perpendicular to diagonal EO at G and J. So that's what we're using over here. And now we actually have to make a statement of congruence. We have to say that angle 3 is congruent to angle 4. And how do we know that this is true? We know it's true because all right angles are congruent. So what we just established is that the two pairs of angles in both of these triangles are congruent. And we also established that the pair of sides in both triangles between those pairs of angles are congruent. So now we could say that triangle EGT is congruent to, and when I set up the next triangle, I want to make sure that the letters are corresponding. So I went from E to G to T in this right triangle. I went along the legs. So I'm going to go from O to J to Y. So we have O, J, Y. And which postulate are we using? Well, notice that we have two pairs of angles that are congruent in both triangles, as well as the sides between the two pairs of angles. Okay, so that tells us we're going to be using the angle side angle postulate. Okay, so we're going with ASA. And now we could finally write the last statement. We could say that TG is congruent to YJ. And why is this true? Well, when we have congruent triangles, we could say that corresponding parts of congruent triangles are congruent, and we can abbreviate like this. If you're worried about remembering the letters, here's a fun way to remember it. You could say constipated people can't take craps, okay? But don't actually write that out. This stands for corresponding parts of congruent triangles are congruent.